we could rewrite 1 over square root of x as the integral of x to the negative 1/2 plus pi sine x dx. And when I integrate x to the negative 1/2, that's going to be, I'm going to add 1 to the power, so it's going to be x to the 1/2 over 1/2, so that could be multiplied by 2, plus pi is just a constant. The integral of sine x is negative cosine x, and then plus c. And so I can write that as 2 square roots of x minus pi cosine x plus c, just to clean that up a little bit. The next one, integral of e to the x plus 5 over the interval from 3 to 7. So the integral of e to the x is e to the x, plus integral of 5 is 5x, and I'm going to evaluate that from 3 to 7 by the fundamental theorem of calculus. So if I plug in the 7 first, I'll have e to the 7 plus 5 times 7 minus e to the 3 plus 5 times 3. So this is e to the 7th plus 35 minus e to the 3rd minus 15. So I have e to the 7th minus e to the 3rd plus 35 minus 15 is 20. And that's pretty much as simple as we can go there. The last one, I can see it's going to be an application of the fundamental theorem of calculus part 2. And so, so I can see it's going to be the chain rule. So the derivative of this integral is going to be, so if there were just a plain x up there, it would just be secant of x. But since there's an x cubed up there, first I need to evaluate that integral with the x cubed plugged in. So I'll have secant squared, secant of x cubed squared, and then times the derivative of the inside function, which in this case is x cubed, so that's 3x squared. So this is secant of x to the 6th times 3x squared. So it's just going to be a chain rule problem.